Sound test. All right. Hello, hello. I will start solving some problems in like 5-10 minutes. Right. I'm sure that many people missed that, but yesterday I did a first stream where I mainly set up the system. Hello, click. We want to do some Codeforces problem solving. I don't know, problems around rating of 2000 maybe. We'll see. Hi chat. Maybe I will choose a problem to start with, and then I will finish setting up whatever I want to do. What do we want? Any suggestions for nice problems? Something with short statement. Choose index, subtree. Maybe first problem we want to something very simple. What is this? Select two indices, replace AI with GCD of both. Minimum number of operations. That seems fine. Okay, that will be the first problem for us to solve today. All right. Okay, and now are we live? I can copy paste the link, provide the link. Here you go. Chat commands. Your browser is not supported? What? I'm using Chrome on Linux. That's interesting. Okay, let me do that from Windows then. Link, command. Okay. And now on Twitch, can you try the exclamation mark link? I think it should work now. Division 1A indeed is usually equal to division 2C. So roughly you will have that div 1A equals div 2C. Okay, it works. Good. Now. Okay, so few checks. Codeforces, we are live. On Twitch, we are live. YouTube, we are live. Cool. The next thing is this. I'm just still setting up stuff. You can think about the problem. Will the stream be available afterwards? Yes, it will be. What is my typing speed? I think I can reach 100 words per minute, though I don't know. It was a long time since last I measured it. Maybe I will do it today. How it feels to be a coding god? Don't know. Don't ask me. Major contest you participate in these days? I mean, in Poland every year we have potyczki. So I did that recently. I was second. So I was second in Poland. And now there is this thing, which now is not in recent actions, but if you... Can I open this website? I'm not sure what will be displayed. Yeah. There is this contest that right now the qualification round is ongoing. Today you have the last day to participate. Do consider that. So it's this link. It's a contest with the final round in Slovakia. I think I will go if I qualify. So this seems nice. It's organized by Mishov, I think. There was a stream yesterday, but I can't find it on YouTube. That's because yesterday I streamed only to Twitch. I did record, but I have not uploaded it. Maybe I will. Okay, next thing is stream chats. Okay. Can you please take some session for problems of fund companies as placement season is gonna start? Maybe. Oh, not today though. Today, competitive programming only. I don't like how this chat is displayed starting from the top, but in Restream I cannot change it. I would want messages to appear just above my head. Okay. Okay, let's solve a problem. That's... What do I have as ACPP? This test thing. What I want is my template. I guess we can do this. All right, we are given a sequence of length 5000 and we want to change all the elements into the minimum. Obviously the element we want to achieve at the end is equal to the GCD of all the elements. For example, if in the input you're given, let's say here, 12, 20, and 30, it's all divisible by 2. If you replace some numbers with the greatest common divisor of them, you will still get numbers divisible by 2. So likely our goal is to obtain the sequence of 2 to 2. We can simplify this and say that now we can divide everything by this GCD that we want to obtain. So instead of this, I want to work with this sequence and I want to obtain 1, 1, 1. The question is how quickly I can get it. So we can start like that. Now, well, actually, problem solving, you shouldn't start coding before you come up with the full solution. But it's not that I'm actually maximizing my performance right now. Okay, and now I want to compute the GCD. So let's start with the first element, and for all the other elements, G is equal to GCD of itself and this element. Then divide everything. All the elements divide by G. And now we will focus on the problem of you are given, well, coprime elements, not exactly coprime, elements with GCD equal to 1, count mean steps to obtain only once. Also, how long do we see the message on the screen if you type something? Stopwatch, test, and this. Did I ever slap tourist? No. Why is it so fast? It's supposed to be hidden after 30 seconds. Unless I need to... unless I need to copy the link again. Embed chat, copy. Okay, it changed. So let's test again. Test 2. Oh, and now it's displayed from the bottom. That's what I wanted. That's great. It's a little bit annoying how you can see on the right hand side a little bit of them. So let's shift. And now it's better. I think it will be on for half a minute. The test 2 message. Yeah, it was roughly half a minute. Later tell me if I should adjust it. right? So now I think everything works. Tell me if that's not the case. Right, now we want to quickly achieve GCD equal to 1. Everything we want to change into 1. In particular, if one number you change into 1, then everything else you can change into 1 as well. Is this comment easy to read? Is the color of gray okay? Can you easily read what is written here? So my target will be change one element into a 1, then apply it to other elements, then need n-1 extra operations. It's okay? Good. And so how quickly can we change an element into 1? We can, for every element, think how quickly we can achieve that. Every element is initially the product of some primes, and we want to get rid of all those primes. Actually, you can think about taking GCD as getting rid of the primes in factorization of a number. So if I take a 6 and I compute its GCD with something not divisible by 2, I will get rid of the 2 in the factorization. So I want to look at those numbers, and I wonder how many other numbers I need to use so that I would get rid of a 2 and I would get rid of a 3. The way I see how we can do it is bit masks, but that seems complicated. I have here a spoiler that this is 1500 difficulty, so maybe there is easier method. But here's what I can see. You have some number and you express it as the product of primes. If some prime appears multiple times, doesn't matter, just look at one of them. Then look at those primes that appear. Think about it as a bit mask of just 4 primes. So there is first prime, second, third, fourth. Think about a bit mask and say this is the current representation of number AI, and you want to get rid of all the values. And you go through the other n-1 elements, and you say you can, with cost of 1, apply GCD, so turn off some bits, and then you will obtain a new mask. Like if you GCD with something that doesn't have P1 and P3 in its representation, then this changes to 0, this changes to 0. That's one possibility. The other, and the time complexity of that will be that for each of n elements, I go through n elements and I do 2 at power logarithm of this roughly. How many primes can we have? 2 times 3, 5, 7, 11. We can have 5 primes in a number up to 5000. So this is the time complexity. But this number is so small that maybe we just can have dp of that. We can go through numbers and we wonder how many GCD operations are needed so that this is the current GCD. Maybe that's better, right? So if I see that the first number is 6, second number is, let's say, 9, then I know that their GCD is 3. So that's what I can do with one GCD operation. And then I don't think I need to do those masks things. Also, I don't need to do it separately for every number. So I will not, for every number, analyze how many operations are needed to change this number into 1. I just generally analyze how many operations are needed to obtain a 1. So that seems better. Codeforces died, really? Oh yeah, it died. Funny. Also, the chat is now too transparent. I think it's, at least to me, a little bit annoying when I look at that. So we want to do this, I think. And in those settings, we want better backgrounds. Okay. How do you conclude that all numbers need to be 1? Why not 2 or 3? I did some trick at the beginning. I said that if all the numbers are divisible by something common, Then let's divide them initially by that number so that we would achieve a 1, though that will turn out not really needed. I'm going to get rid of this trick. So we are not changing everything into a 1, we are changing it into the GCD of all. That's what we will do. Okay. So we will have a DP where I'm interested in the max element. DP of max plus 1, comma, let's say infinity. I will define DP in a moment. Okay, DP of G will be defined as minimum number of steps to achieve, to obtain elements, to obtain value G, let's say. That's the definition. For every number that I see in the input array A, when I see this number, I can apply it to some value that I already obtained. So for every possible value already, some, let's say, value, from 1 to max, I can, with cost of 1 operation from value, I can move into GCD of value comma x. This is the transformation I can do. So I will say that dp of, let's make a temporary variable, dp of tmp is minimum of itself, and dp of x plus 1, no, dp of value plus 1. So you could already obtain value made of few existing values, plus 1 extra operation, you can now obtain tmp. Additionally, when you see any value x, you can say that you can obtain x with cost of 0. Then at the end, I'm interested in what is the cost of obtaining the GCD of everything, which is just the smallest existing value. So now for everything, if you're not infinity, then you're the smallest value that can be obtained. And what we want to print is dp of I, plus the remaining n minus 1 elements I want to change into the same value. And break. That should be it. Codeforces back. Good. Copy. 453 didn't work here. Well, the value 1 is there already. Oh, if other values are already equal to the GCD, this is a special case. It's an edge case that I would miss if not for this sample test. Actually, I did miss. I would get wrong answer if not for this sample test. Will you solve problems from random topics? Yes, I think so. No, what? Okay, so if what? Maybe let's count others. Others is 0, or already is 0. For every element in the input, if it's equal to this minimum that I see, then already plus plus. This is the number of elements that should not be changed. Or maybe let's, okay, this is the number of elements already equal to minimum. They will not be changed for sure. So I will here only add the number of elements that need to be changed. That being said, at least, at most n minus 1 should be changed, so minimum. It's not that all n need to be changed additionally, because this already computes number of operations needed to obtain 1 minimum. Let's try now. Works. Not allowed to view the requested page because I'm not logged in. Yeah. Are political problems in random topics too? I don't think so. If number already GCD, then skip it. That's correct approach. Stuck at 1300, can anyone guide me how to get past it? I mean, how many months or how many hundreds of problems have you solved at this level? I think at that level, what you're likely lacking is some like, math / logical skills. So maybe what might help, but it's hard for me to guess, is getting a book with math problems, math exercises, and going through those. What programming language do you use at work? Kind of what you're seeing right now is my work, so C++ mainly. Okay, accepted. I wonder if we should try the next problem from the same contest. I don't want modifications again. What about problem C? Do we want a hard problem? Probability. It's probably. I want to read it. Let's see. So this is the problems link. The command should also work. Let's see. We have n monsters. If each one starts with some health points, HI. We don't want to kill them. We want to reduce the HP to exactly 1. So far, very similar to the previous problem. Maybe now the statement will say, with one operation, you can take 2 monsters and change one of their HP into GCD of the 2 values. We attack the monsters for m rounds for each round. The sword shines with probability P. Then we can choose whether to attack. If we don't attack, nothing happens. If we attack and the sword shines, then all monsters will be hit by 1. If we attack and the sword doesn't shine, so 1 minus P probability, we can choose one of the monsters and hit it by 1. Before we choose whether to attack or not, we know if the sword shines. If the sword shines, we can only attack all monsters. We want to know the probability of achieving the goal. Number of monsters n is up to 20. M value number of rounds up to 4000. The health points initial up to 400. And the probability is expressed as an integer from 0 to 100. Glorious Polish King has returned life. Yes, I have. Have a good recommendation from AdCoder if you want. Starting from maybe next week, I need to collect good suggestions on Discord. So, GodGamer, I will try to maybe organize suggestions like that. Today, I will just solve a couple of problems from Codeforces. Ayush says that you solved about 30-40 problems of 1300. Then the follow-up. First thing is, it's not that many. So it's not guaranteed that if you solve 30 problems at some level, you will, advance to the next level. Second thing is that it's important if you solve them indeed, or you looked at the editorial. Maybe you give up too quickly. Maybe you read the full editorial and then you just implement it instead of reading a little bit and then solving. Isn't the time complexity n squared log n in problem A log because of the GCD? Lasha, you might be right. Maybe there is amortized time complexity going on. So here we have, for each of n values, we iterate this, and we have the GCD. That being said, GCD time complexity is limited by the factorization of value or factorization of x. If you iterate all values from 1 to 5000, and for each of them you compute its GCD with something, I'm not sure if the sum of this is n times log. If so, it will be very small log, so with very small constant factor. So, like if for all numbers 1 to 5000, add up the number of different divisors. Is that the proper limit for GCD? No, it's not. It's like, it's a Fibonacci number. I don't know actually. Is this code n log n? If let's say x is, take something from the input, let's random from 1 to n. Now for every value from 1 to n, compute GCD of x comma I. Is this code n log n, or is it smaller than that? Because GCD will hit the worst time complexity of logarithm for very specific pairs of values, like for Fibonacci numbers. Maybe, just maybe, this amortizes to n operations. If somebody has time right now, you can check this code. You can check if this seems to grow logarithmically or with constant trying different n values. That being said, I will move to this problem. Why some of your submissions got skipped? Is that the case? Where did you see that my submissions are skipped? How do I... Where is like my global submissions? Here. I don't see it. Or did you ask somebody else? What is my dog's name? Oscar. Extended Euclid algorithm. I mean, it's okay to memorize it. Why don't we see the chat? Wait, test. What happened? Why the chat doesn't work now? Instead is to see your submissions. Wait, so I've tested 2. Twitch. Oh, I'm not signed in here. What about him? Test 3. Okay, so this is displayed. Test 4. Now for some reason the YouTube comments are not displayed on the screen. Why can't software just work? Why? If software just worked, we would be out of the job. That's a good point. What about now? Test 5. Okay, test 5 is displayed. Good. Maybe now it will work. Should we solve the problem? So it seems that when when the sword shines and we can hit all monsters by 1, we do it. Right, so with probability P, the sword shines. If all HP of I are greater or equal to, use it. Else, do not. With probability 1 minus P, the sword doesn't shine. And we will likely hit a monster with max HP. I don't see why not. Unless this causes the HP to become very uneven. We can hit a monster by 1 health point with max HP. And we might not want to do it, for example, if all the values are 2. We might want to wait for this to happen and just use this operation. Also, if the values are quite even like this, then also we might not want to do it. So there are some values in the input. We can sort them, and for sure we will use the operation of hitting single time as long as the values are not equal. And then when we have this thing, we have a decision. Do I want to hit one of them and then spend some extra operations or not? Clearly, the exact distribution of health points is not that important. So it seems that the only 2 parameters that are important from the sequence are the minimum and the sum. The minimum goes up to 400. The sum, well, the sum goes up to 400 times 20, and is very small, 20. Okay, maybe we should separately consider the 2 phases, because first the sum can be big. So I would say in the first phase, what's my diet before the contest? It's normal. Just don't eat something very heavy. I've recently read a comment about somebody from the chess community that they are careful about what they eat for breakfast before the competition. And indeed, chess tournaments, they can be very long. You might compete for almost a full day. I would say it doesn't matter that much for Codeforces rounds, but for 5 hours of ICPC or Olympiads, I think it is important that you don't need something very heavy, such that you feel tired and you feel lack of energy after a few hours. But for Codeforces rounds, I think you're not that limited by your body. For 5 hours and more, you might be limited by your body. How likely it is to get into top 10 teams in ICPC World Finals with Codeforces rating of 2500? If all 3 of you have 2500, then 50%. If only you have 2500 and the others have 0, 5%. Indians are the biggest cheaters on Codeforces. I might want to see statistics of cheating per capita, so per person. How to prepare for ICPC if you are X rating? Well, solve ICPC problems. Okay, phase 1. Hit greedily. Hit greedily until everything equals. This might be separate phase because the sum here is crazy big, and you likely don't want to keep it as a DP state in something more complicated. I'm not sure if this is needed. Phase 2. You got everything equal. Also, we want to scroll. Everything equal, and then you have some kind of choice that we will handle with DP of whether now we only rely on operations of this one kind. So if, for example, every number you have is a 3, you can compute what is your probability of winning until the end. You know how many rounds are left and what is the value of P. So you know, if I only want to hit everybody at the same time, and that happens with probability P, what is the chance that I will get everybody down to value of 1 in time? Or you have the alternative in form of, actually, I want to hit and keep hitting. And then the state is that some number of monsters is decreased by 1. So easy part here. Easy part is to find probability of winning with shining sword only. Shining sword only. And then harder is that we use everything. We use both types of operations. State is the current minimum and count of minima, because that's enough. Everything else is the minimum plus 1. This state is smaller than the sum of values, right? This is just minimum is up to 400. The count of minimum is up to n, which is 20. And the reason why I immediately split into those two phases is just my intuition that for non-easy problems, you don't want big states. For now, in my head, I do not know the time complexity that I'm looking at with this DP. But it seems that we will need to do this separately because this is better. Now let's think about exact DP states. In this first phase, I have the sum. I have the minimum and the sum of values, right? Does that fit in time complexity at all? Minimum is up to 400. The sum is up to this times that. What is the multiplication of that? 5 zeros, so 16, 1 million. This is 400. Okay, that's too much. Actually, I can also do this. No, why did I use M? M doesn't matter. This is the state. That's not that bad. And actually, why is this not everything? Because there is the number of rounds, right? Rounds remaining, of course. And then you multiply by 4,000, we lose. Okay, we cannot do this. Instead, it seems that we need to do it with combinatorics, so it will not be DP. I can iterate for how many runs it will take to hit everything until equal. So for number of rounds that I spent from 0 to something like M, for then the final minimum from 0 to 400, I want to, with combinatorics, find probability that I want to find probability that in that many rounds get everything equal to this. But here I think it's hard to avoid double counting. Well, I might need to finish the stream in a few minutes. We'll see. But if we do this with combinatorics, we can do that, because if you know how many rounds you spent, you know how many times you apparently hit for everything versus you hit a single monster, and then it will be some binomial coefficient for, and multiplied by p to some power and 1 minus p to some power. That's the easy part. But oh, one more thing, we need to output the real value, so maybe we will use the fact that big precision is not necessary. That might help. It might mean that some unlikely states should not be considered. Okay, what if this part we do with a... I know, something was redundant in the previous DP that I wrote. It's enough. I will not do this with combinatorics. I will do, well, better not remove it completely. Most likely I'm not doing this. Let's move this outside. Instead, it will be DP of the current round and the number of times I hit everything. So full hits. This is up to 4,000. This is up to 4,000, so I can handle that. And this is enough because I know all other hits were for a single monster, so I know how the full sum decreased and how the minimum decreased. The DP, this will be double. This will be probability that this is the state, and so far I didn't make everything equal. Okay, that's the correct first phase. Is the sound low? I can barely hear on 100%. After today I will try to change that in settings somehow. Okay, I need to finish the stream. Sorry about that. A quick look at the editorial. I'm curious if I'm far from the correct solution. What was the name? I will finish the stream in 1 minute. If you don't want spoilers in the editorial, you can just close now. So use dynamic programming. We split into 2 phases by some nature. So we use this to indicate the probability that the sword did not shine exactly j times in their first rounds. Yeah. Did not shine. Why is this better? I have a slightly different definition of J. I was on the right track. I would solve it. Okay, sorry that I'm finishing so quickly. The stream was less than 1 hour, but at least we figured out some display of the chat. I will later think where exactly to place it. I'm not entirely happy with it. Maybe it will be here. Like here, the issue is that I'm covering some part of what I'm typing. Maybe this is a good idea. So is my face that important? I don't know. Okay. I think I will stream again tomorrow, similar time, maybe around noon.